Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about pick and place machines. So let's dive right into it. Now first, this is a specific tool designed for one specific task, that is mass production. Basically, this puppy takes one, makes millions of them. Like, it does not matter, like you're not going to think about this if you're only making 1, 2 or 10 or 100. If you're thinking about making 100,000, yeah, this is your guy. Now it's possible to make this because of three core innovations that happened recently. One of them is PCB. I have already made a detailed video about that. Then we come to SMD, surface mounted devices. Now that itself is not that crucial until you realize that PCBs are kind of strong structural matrix. Now to drill through them, that wears out your drill bit, that increases the cost. So if you have a PCB that has like 5 holes versus you have a PCB that has like hundreds of holes for each component, the price of that hundreds of holes will go up. On top of that, even if you have a lot of money, what the hell are you gonna do about time? Like, again, it's gonna take time. So fundamentally, these two things made it possible. Then we come to the third binding ingredient, that is solder paste. Now this solder paste is a kind of very good mixtures where it has solder itself and flux itself, and it has a kind of a high viscosity where it can hold it down temporarily as a glue, and then you have to just bake it and it will do the soldering for you. So all these three things allows you for super fast mass production. And then when we are talking about this machine, it's just a variation of CNC. Basically CNC is whatever is computer control, basically computer numeric control, that's CNC. You can have a basically laser head, it's a CNC laser. If you have a 3D printer head, it's a 3D printer head. So you get the point. CNC is not that complex, however it does require a custom head for this job. And there is a whole ecosystem because this allowed humans to have a mass production. Like if you go to China and like you will see like what exactly is making the ability granting the ability for Chinese people to make such a large mass production equipment. This is the whole thing, pick and place machine. Like you go to any factory, what do they have? Pick and place machine. There is a whole ecosystem. How do you, if you are providing equipment to CNC, basically CNC pick and place machine, there will be a whole ecosystem that you have to follow. So this is very foundational technology to our world. Now, what's the logic behind it? The logic is very simple. Mass production is just repetitive work. Like, it's fun. Think of it this way. Let's say you are a YouTuber, you made a PCB design and you're like, everything is awesome. Let's say this smartwatch, whatever have you. That's my desire. But let's say you built that. It's awesome. It's fun and games while you're making one time. Even prototyping. Let's say you went through 10, 12 remodification, and once you have final product and you're like, hey, what if I sold this? Let's just say low volume, where it's like, hey, I'm gonna only make 100 pieces and then I'm gonna sell it. Awesome, no problem. You did that, then you realize like doing that 100 times is very tedious and painful, and you're gonna make a lot of mistakes, especially the components are small. So in those sort of scenario, that's the problem when you're dealing with 100 components. Imagine what will happen to you if you have to make thousands of them. So that's the whole thing. Mass production is just repetitive work. You do not want human to do that. So how the heck you do? Like, what are the steps? Step one, pick the part. Basically, whatever it is, resistor, a microcontroller, whatever have you, whatever you have to pick and place on PCB, you have start with that picking. Then we come to the tricky part, that is orienting the part. Because again, if you are talking about microcontroller, you may be able to pick it where the pin number 1 is like this, but your PCB may require it like this, so you have to rotate it. So that's the orientation of the part, and we utilize cameras to help in that. Then we place the part. You pick the part, place the part. That's the one thing. And then how the heck you make sure those parts stay there where you put them is because solder paste will hold the part. Like, it's acting as a temporary glue. Now solder paste is very critical and frustrating to deal with, simply because especially when you are talking about ball grid array, even if you move your microcontroller a little bit, yeah, bye bye, your equipment is going to be ruined permanently. So that's a very tricky thing. So you once you have done that, like once you have laid down all the components, placed every single component on PCB, you have to be extra gentle with that equipment. Now again, big components don't care that much, but small ball grid arrays or fine print equipment, yeah, that is a really delicate operation. You have to be very mindful with that. And then once you have that, what we call populated PCB, your PCB have everything that it's supposed to have, it has to go through what we call a reflow oven. So basically you're gonna have your pick and place machine, and then it's gonna go through this oven. Now this oven looks like oven. It is an oven, however it's ludicrously expensive. Reason? Because it has temperature control with a proper defined gradient. Now that's what makes this puppy successful, because if you don't have this temperature gradient, there's a very good chance if you have plastic components, you may simply end up melting them. If you have something sensitive, let's say some CCD or CMOS, you may end up damaging them. So there is a very serious line that you have to toe in order to make sure this puppy works. So there will be a very gradual ramp up. Now that ramp up is designed not by the oven, it's designed by the components that you are doing. So if you have a lot of heavy component, that ramp would be much harsher. If you have like gentle components, you will gentle as in like very small components that heat up too quickly or too down. That's you have to do. Like before every production run, there will be like a lot of science engineers that's gonna sit down and they're gonna do multiple what you call test run, and then they're gonna figure out which quote unquote profile is the best. Because if you don't have the correct profile, your board like you may send 100 board and you may get 50 working, but do not even expect about 50 basically 100 working. So in those you're gonna have ramp up, then you're gonna cook off. In that cook off period, basically the SMD I'm saying basically the paste turns to actual solder and does the job. Then you have to have cool down, and also cool down, because if you cool down too quickly, you're gonna shock the materials and you may literally have things popping off of that because of the thermal shock. So that is also a gradual cool down period. That's why if you type a resoldering oven, it's very expensive because of the control. It has to be ability to like properly rise the temperature, properly drop the temperature in a defined manner. So this makes pick and place machine functional, because if you don't have this reflow oven, yeah, bye bye, it's not gonna do anything. So pick and place is just step one. After that you have to have this reflow oven. Now let's understand the head part of it, because I specified it's just a CNC that's doing one thing again and again and again. So how it's doing that, that's the job of the head. Now in early, as in like 1990s, cameras were very expensive, so consequence these machines were very expensive, consequence the products are very expensive. But nowadays, because camera is so cheap, instead of utilizing ludicrously advanced encoder or decoder systems that will allow precision and allow high speed, but they will be very expensive and your machine cost will go up, we simplify everything and we just rely on camera and vision system softwares to correct that. It's like, okay, let's say I picked up the microprocessor, but it's never gonna be perfectly aligned. How the heck like you're gonna compensate for that? Just look at it through a camera, and the camera will help you. Hey, like this has like 8mm offset. Then you send that data to CNC part. It's like, hey bro, do 8mm offset on your x-axis. So that's how it works. Now pick and place, because we are talking about small parts and these parts are fragile and very sensitive, we utilize vacuum. So you do not want to clamp these parts, so we utilize vacuum. They are very simple and it does work. Now depending on your production scale, production volume, you will have either multi-head system. Now these systems are expensive AF, but they are only way to do this. Like think of this way, the difference between a multi-head and a single head system would be, let's say Apple came to you, it's like, bro, make me PCB. You're like, I got everything. Now if you have to make 100,000 PCBs, that could take you around 1 month or 1 week. That's the difference of having multi-head. Now be mindful, the multi-head will cost exponentially higher. So it's up to you. It's depending on production requirements. Some companies choose for multi-head, some companies choose for tool changers. Now tool changers are really good for small production and small batch operations, where you're just gonna have like a machine just gonna to plonk the nozzle, because based on your basically things that you are placing on them, your nozzle size has to change. Again, if it's a big product, you need big nozzle. If it's a small one, you need a small thing. So nozzle changes has to be done. And again, this is a slow operation, but does allow for very basic machine to do a lot of jobs slowly. Then you have multi-tool, where you could literally have, like, let's say you need 8 nozzles, you will have 8 heads, print head, quote unquote, and it is gonna pick up 8 different component in one go. That will simplify your production speed. So this controls the production speed. Production speed generally can be measured by like components per second, component per minute, or component per hour. Now some of the high-end mass production machines, those bonkersly high. Those are generally used for making your mobile phone, PCBs, motherboards, those things or equipment. Those are high volume enough where you can utilize multi-print setup, because most other times people are no longer going for multi-head, they are going for tool changes, because these machines allow for much more dynamic operation. Basically, yeah, let's say one moment you are making LED driver, another moment you are making LED panel itself. You can switch back and forth quite effectively. That's why each of these tools have their pros and cons. Now we come to the SMD reel part. Now this is the aspect that you have to think, because think of this way, that pick and place machine is a printer. How the heck are you gonna feed that? So that feeding part is SMD reel. Now surface mounted is well. Now this tape and reel allows small components to be fed, like basically transistor, diodes, resistors, all those things, or very small things, those can be fed through reel systems. Now these reel, that's why I specified there is a whole ecosystem. Like if you go to Samsung Semiconductor and be like, bro, give me memory chip, they're not gonna give you a memory chip like this. They're gonna give you memory chip in that, and you're gonna ask them, it's like, hey, how much do you want? Now they may already have a standard. It's like minimum order is one reel, so that one reel could contain, let's say, 10,000 pieces. It's like, yeah, minimum order is 10,000 pieces. Or you may be like, hey, I'm planning to make 50,000 phones, give me 5 reels. That's how it works. Now there are many places where you can buy just like small chunks of these reels, and the reason for that is like many hobbyist shop, they will buy these are very expensive investment. They'll buy that and they'll just keep chomping it off and selling it to you, so they will make a bit of profit. So again, bulk buying does reduce the price, but what the hell you gonna do with like 10,000 LEDs or 10,000 memory chip? So that's the whole thing. Now once you are talking about big parts, like these things you can design, it's a physical thing that you are rolling on top of it, so there is a size limit. You're not gonna do that with like a large south bridge chip or something like that. For that we generally utilize on trays. Now these trays will be like fed into the machine, and machine is gonna pick and place, and that's why camera is so important, because again, it's a tray system. This is a feedback loop where you can have like, okay, place 1, place 2, place 3, place 4, but on a tray it will like 1 2 3 1 2 3 1 2 3, so you need cameras to do that reliably. And many times you will have like microcontrollers specifically are known for that. It's like they will come in like a tube, and you have to have a vibrator that's going to shake them into a tray, and then camera has to pick it up. So these sort of things are normal things. Small strips are generally used for hobbyist level job, where you only have to make like few hundred pieces. Now do it yourself. Now this is one thing that you have to understand about our modern world. Like we can do amazing things in our house. So factory is only suited for large print jobs, that you have to understand. Large, if you are going to talk about like making 10,000 piece, don't even think about these machines. But if you are talking about only making 100 or 1,000, that zone, 100 to 1,000 zone, this is the only option you have. Like, can you try to do that manually? Yes, but it will take a idiotically large amount of time. And there are companies that do small batch runs, but they will charge you a lot. Like per piece will go up in price. So again, if you can afford that, go YOLO. But if you can't afford that, then you have to utilize these machines. And because these are just CNC machine, and because CNC machine are becoming ludicrously popular because of CNC mills and 3D printers, whole ecosystem has been opened. There is a freaking company, Open Builds, that allows you to make CNC for whatever you want. Laser cutter, they got the CNC for that. 3D printer, they got the CNC for that. Plasma cutter, they got the CNC for that. So it's just that it's like just a different kind of CNC machine. And because there is a lot of desire for flexibilities and rapid prototyping and reworks, there is a whole world which there is a demand for this. Basically, there is a large demand. Now that demands leads to software being free and open source, and that create a scenario where people can build it. It's like even in old days, as in like 1990s, you could have built this machine. It's just like forget about the software. Like those software were patented, locked behind lock and key, actual lock and key kind of scenario. Like those software are protected as hell. Nowadays it's just open source. Heck, you can buy 3D printers that have open source firmware into that. So all this ecosystem where you have cheap hardware and free and open source software allows these sort of machine to be developed in home. I have provided video down below where some people have made amazing machines. Heck, like if you don't, it's like it's cheaper to make that machine and then do small production runs than to like actually even think about going to someone and it's like, hey, can you do that? It's like that's how amazing these things are possible. And again, these are amazing thing that every school and not school would be too less, but like college, university, they should utilize these things. And again, if you have a maker space, but again, if you are running a maker space specifically where people do like small batch productions, then it's useful. Other than that, it's not that useful. But as a product, as a learning aid, because this utilizes visual aid very rare. Like if you want to develop optical systems, this is one of a very good tool for that. So there is a lot of potential there. Like if you truly want to do that, like there's a whole ecosystem of like firmware, patches, bugs, fixes, everything is already done. It's just like buy and assemble it yourself depending on your needs. So you need, let's say, big reels, you buy big reels, so you make the system for big reels. Or if you need multiple small strips, people have made PCBs that will hold that small strips reliably accurate, and then you're gonna pick and place. So lot of option in DIY. If you need to do like small batch runs from 100 to 1,000 or even 10,000, like you can do that. So this was my presentation on pick and place machine. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. And subscribe, press the bell icon if you're free. And as always, thanks for watching.